Welcome back to the classroom. My name is Mr. Wong. Today we'll be going through the 2021 HSC Physics paper question 30. This is to go through module 6, inquiry question 1, which is how charged particles behave in an electric field and a magnetic field. So I'm going to grab my highlighter and I'm going to go through this question. Come along with me and we'll see how do we approach questions like so. We have, in an experiment, a proton accelerates from rest between two charged plates. They are parallel to each other. The spacing of the plates is 12 centimeters and the proton was initially positioned at equal distance to both plates. We are ignoring the effects of gravity. So here we have. What we can anticipate already is in an electric field, a charged particle will be attracted towards the opposite side. So a proton is positive, it's going to be attracted to the negative plate. That's what we know for sure. Now, it had an original velocity of 0, and the fact that we're moving it means we've applied work onto the charge, but it also means a force must have been applied in order to make this proton move, or at least change from its original position. Go to question A. We have the electrical potential of the proton recorded in the following graph for the first 5 centimeters of its motion. On the graph, sketch the corresponding kinetic energy of the proton over the same distance. So we are ending the change at 5. Okay, well, we already know from the question that the original velocity was 0. So going by our formula, half mv squared, if v is 0 at the start, that means kinetic energy must be 0 at the start. Okay. The next question is, where does it go at the 5 centimeter mark? Well, this is where we go back to the law of conservation of energy. It states that the potential energy plus the kinetic energy should equal or combine together will give you the total energy. So the law of conservation of energy states energy can't be created nor destroyed, but it can be transformed or transferred. So whatever energy we started off with potential, that's being transformed into kinetic energy as we go down. Now we've passed 5 centimeters. If we actually have a count, we move 1, 2, 3 squares down, which means that by the end of this, kinetic energy has increased by these 3 squares up. So it will look like a straight line like so, and this is the kinetic energy of the proton. And that's how you do this question here, using your understanding of the kinetic energy formula and the conservation laws of energy. Okay, moving along. It says the experiment is repeated using an electron in the place of a proton. Now, the first thing we can say is a proton is positive, an electron is negative. So we can already say it's moving in the opposing direction. So I'll just redraw the chart that we had. We had the positive side at the top, or at least the plate. We have the negative side at the bottom. So if we have a proton, which is here, it is going to go downwards and change color to represent an electron. It's going to go up. So that's sort of one difference that they will have in motion. Because they have different opposite charges, they're going to go in the opposite direction. Okay, so let's start with this. So the electron is negative and the proton is positive. They will experience a force in the opposite direction. So the electron moves to the positive plate, whilst the proton moves to our negative plate. And the reason why we already said it's because of the electrostatic forces. We might even say electrostatic force in the opposite direction. Okay, so that's part of it, but if you actually have a look, there are 3 marks to this question. I've given an identification of their differences, I've given an explanation, but there's more to it. So to speak, we can even talk about the mass of the 2 particles. An electron is a lot smaller than a proton. So if we look at this, they also have a difference in the speed in which they will move from one part of the plate to another. There is a difference in acceleration of the electron and our proton. How can we show it? Well, based on the formula, Newton's second law, and the force that the charged particle experiences is Q, the charge of the particle, times the electric field strength. Now that is constant when you have 2 parallel charged plates. So I can actually find some information about the overall acceleration. So therefore the acceleration is the charge over E divided by M. Now the electron and the proton have the same charge, just in the opposing direction. So that's kind of what we see with that. However, the proton has a much higher mass than the electron. So what that would mean is its acceleration would be slower than the electron. So as mass of proton is bigger than mass of the electron, the acceleration of our proton is smaller than the acceleration on our electron. So what we can say is the electron reaches the charged plates, or the charged plate, faster than the proton. And that's how you solve this problem here. Okay, so if you found it useful in understanding how we can apply the law of conservation for particles in charged electric fields, or henceforth how to do an explain question, how to break it all down like we've done so in this video, well, hit that like and subscribe button if you haven't done so already, and I'll go through other questions of these types in the future as well. Thank you for watching, and thank you for your support.